Hey, I'm back. Alright, so I've been thinking about how to support infinite canvas in like both the scale and the XY axis for panning infinitely. I think one thing I need to do is rework. Hey Finkelum, greetings. I need to rework, I think, the coordinate system. Eliminate all the floating point numbers first. But before I get carried away, let's just try to do a proof of concept, I think. So here's what I need to do. Where did I put my... Wait. Oh shit, it's far. Dang, I have too much stuff. Low frame rate. Looks odd. I can't tell. Maybe the colors? Doesn't look low to me. Maybe it's on your side. Oops. Well, that's the bug I gotta fix at some point. Yeah, I don't think there's much I can do. These lines, those are just drawings. So I'm able to like draw stuff. Oh. Wait, what? Oh, it's not plugged in. So this is a drawing application I coded. It handles pressure sensitivity. So what am I coding? I want to be able to have infinite canvas. So like here, right now it's capped to, I can't zoom closer. And then here I can't really zoom further. Well, I can if I force it. I guess I have more stuff drawn. But for now it's hard capped, so I can't see all of this thing. I can actually hotkey this. Nice. Big. Alright. So one issue that I run into is floating point rounding issues, I guess, or floating point numbers. They can't be infinitely precise. So if I uncapped the zoom and then allow like infinitely zooming, at some point you start having lines that flicker because the precision becomes worse. So I think what I have to do instead of having like these start and whatever be vectors like this, floating point numbers, they have to be whole numbers, I think. So the first start will be to have whole numbers, no floating points. Second part is that I think my data structure, the 3, this thing, my AABB3 has to be recursive. So like for each one, they have a specific precision. And then if I zoom in too close, so let's say like my camera is here. And then I'm drawing. Let's use blue, I guess. So you're drawing on this coordinate system that uses whole numbers instead of floating points. So those are like discrete. And then if I zoom in, now my camera is here. Instead of drawing on this grid, I should draw on a new, smaller grid. Oh, what? And then this should be a recursive process. And then, so the tree itself can be an element. A bit like a line. So the tree itself can have its own AABB. Okay, but let's start by doing a proof of concept, just to see if it works. So I'll keep floating points for now. How do we do this? When I create a new line, and then the grid itself is based on this this value down here. So this is an exponential. So I can say 1, 3 is valid, for example, between, like, to be able to draw precisely. So instead of having rounding, like floating point numbers, you want whole numbers so that there are no like rounding errors or whatever. But then if you're zooming in too close, then the grid becomes really big and you're not able to draw precisely. In other words, you need to be drawing not, let's say, from the exponential from like 0 to 4, but like, let's say from -4 to 0. And then if you zoom in even closer, then you would draw to the next one, next one, next one. So within a range. Always picking a grid that is small enough that if you zoom close, the grid would be still smaller than the pixels. So like the whole numbers, the size of the grid would be smaller than the pixels, which allows you to draw accurately. And if you zoom in close and the grid is bigger than the pixels, then that's when you need to draw to a different grid that is smaller again. All right. Right now I have a visual on the side to show me like a sort of like allows you to feel how close or how far you are. I guess this would be something that if like this shows me the range of the current grid, I guess. If I go even closer, then it would go back down, like, I guess it would just loop. That would be fine, probably. So you can still get a feel that you're getting closer or further. How do you get the feel of the whole thing? Or is it a case where this value max, when I've determined the length, I guess this could be the smallest exponential so far, and then the biggest one so far. And then if you zoom out further, then it would like just change the numbers here, so the length would just readjust. I guess that's fine. Then I can still zoom out more, and then if I start drawing, then if I yeah, okay, we'll see. Alright, so step one is I need to start to be able to recursively. So let's start with like the grid density. Grid density. So let's say that I'm drawing the line. You end up in create line. I see. Oh, I see. That's funny. Wait, that was wasn't that a bug? We didn't get into this create group. I might not get the release. Huh. That's gonna be a bug. I'll need to figure that out, I guess.
Rejuvenation, revitalization, reincorporation, rebirth.
In view. Oh, didn't I have... I did have this before. World scale. I thought maybe this wouldn't be required anymore. I guess I do need it. Oops. I forgot how I coded that, but it's kind of cool. Alright. Let's do a little thing to show me. When I do show debug, let's also draw the position. Mouse world. Oops. Oops, what is this? I pretty much found the 0. Okay, 0, let's say. Alright. That's like the center, almost, right there. Okay, that's the center. So that means here is like, yeah, pretty much. So right now, this radius thing, it's default to 10. And then I did this math to be able to figure out the value, and I have a clamp. You can go all the way down to 0.5. Hey, welcome, Topologist. Doing pretty good. Monthly stream, yeah, my yearly stream. I've been meaning to code this for a while, so I guess I need to change my code. Here I'll show. There's an app for the iPad called Endless Paper. It starts off on, for example, this. So this guy has drawn like a bunch of stuff. Then you're able to zoom in. And then you can like keep drawing at every zoom level, non-stop. Then you can just keep zooming in with more things that he drew all the way down there. Yeah, and then he's just zooming in and there's no limits, you can just keep zooming. So I'm coding like something that will do something like that. But this one is an app for the iPad. Mine is gonna be cross-platform. And I think it's gonna be better too. Because if we like look at how they do this. Wait, I just saw. If we look. Their lines don't look very good, I think. Mandelbrot, yeah. This guy does a lot of them. Bum, 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 bum. I have an idea for how it would work. And I have something that I think works. So now I'm coding it. There are still some things that I didn't solve. For example, it's easy when you zoom out to not draw the small lines. When lines become too small, not to draw them. But how do you do that for the big lines? So let's say like you draw like one big line and then you zoom in. You could end up with like a lot of really big lines, right? Like let's say you put like one... No, those are lines. They're like... He's drawing those with a pen. Or maybe this app allows you to put the... Yeah, it should be vectorized. It's hard to get info. They probably wouldn't want the people to know exactly. Yeah, it does look like pixelated. Yeah. I would need to see like a save file for this to... Yeah, so that's something similar to what I'm going to do. I have a data structure called an AABB3. And then I'll, instead of having an holding lines, I'll have it hold lines or another AABB3. And then each one of those can have their own coordinate system. It's pretty powerful. It's the same thing that they use in Box 2D. Coded my own though. This thing. It's very simple. There's a bunch of like 3 balancing stuff. Then ultimately it's all inside of an array. Initial capacity. So you have like your nodes, AABBs, and then the items. It's really fast. The difference is that, yeah, Quad 3 takes more data compared to... maybe I can find the presentation. In 3D, they call it like BVH. Look at this. Dynamic bonding volume hierarchies. So AABs are really simple. It's just like a min point and a max point. And then you can have like, let's say you have an AABB, AB. Then you can combine them to create like one called C. It's very simple to unionize them. In mine, I don't have this, but I could implement that. Having an array. So you can see how... Can't I zoom? Hello? You can like group shapes, and then there are like there's coding to pick good shapes, but it's very like then you can know like if you're hovering something or what's on the screen or things like that very fast just by grouping the objects. So you can see what it looks like. Yeah, you have A, B, C, D, E. And then it all the shapes are part of the tree. And then you don't care. Like, you don't care if something is, like, let's say left or right. It doesn't matter. So here they did, like, 2 it has A, B, C, D. And then 3 has the E, F, G, H, I, J, K. So like as you're traversing this tree, let's say I have my mouse here, then you can like go, does my mouse hover this box, then I can go down this, or if it's hovering this, then I can go down on this side. And then it doesn't matter, like unlike a quad tree that has to be like, is it like this quadrant or this quadrant or this quadrant? This one is like you just have one choice or another choice, or sometimes both, but you know it's both. Well, you know, like this one. So if my mouse is here, I'm at least inside of 1, and then I can check, am I inside of 2? No. Or inside of 3? Yes. And then you can say, am I inside of 6? So that's like this one right here, EF. So no, and then this one no, so I'm hovering nothing. Oh, my camera is starting to... I guess because my screen is... Oh yeah. So yeah, it's efficient, easy to implement. So then here there's an example code. The one that I implemented is instead based on the Qt framework. So it's a port of this code. I guess it's not here. Library source. Shouldn't it be here? ducks. Odd that it only... But yeah, it's based on that. Yeah. Probably similar. What I like with this, it's that it's so fast to update the AAB3. It's like really fast. And the queries are also really fast. When I did the quad 3 and then I compared the two, this AABB3 was just way faster. Alright, what was I working on? So I need to decide how small a grid. So I guess it should be like something like 10 times, right? 2. Where did I go? I guess in practice then I can have my grid be like really fine and then have like -3. So at most the grid should have a range of like 3 exponential. Then you'll have like some 34,000. So the unit here is 0, 0 in the top left. And down here like this is 34,000. And then if I use whole numbers, then that's pretty, then that it won't matter how much pixel, like how much of the grid I'm wasting. Alright, so I guess I gotta try it. Let's see. One thing I didn't figure out is how do you manage on the XY axis? So let's say like this is your canvas. Yeah, well, I guess in practice it's like a square pretty much. And then I don't know like how... Okay, let's give myself room then. So let's say like this is one grid, one like whole AABB3, where like this side is like minus the int, how do you call this again? Max int. And then min int, it's like minus 2 million. I guess I use a signed integer, yeah. Min int, and then here there's max int. So each one of those has its own coordinate system. Yeah. So those can be stacked from like min int all the way to max int on both sides. And then I can have, oops, same thing. Maybe I should make this smaller. Then max int. So like those would be contained in like something. I don't know like how big it would be. And then this bigger thing also has its coordinate system with like min int. And then max int. It's hard to imagine, right? And then, yeah. I don't know how I handle lines that cross. Or is it the case where I should like overlap them a bit? Yeah, recursive. So like this big thing is like, let's say an AABB3. So this thing has an API. And then let's say like for not this one, for example, contains lines. And the line has like a start, and then it really the important thing is that it has an AABB, which just is like the lines left, top, right. So it becomes like a rectangle. So like the line has a sort of size because of the radius. So it gets expanded a little bit. So I think eventually these become ints, and the radius also becomes an int. But then I make my grid, like relative to my screen size, would be like a lot smaller. So in the end, it's like you have floating point numbers. but they are always whole numbers. They don't like map one-to-one with the pixels. Then if you zoom in closer and the grid becomes too big, then you go into a lower level. So essentially like draw on this one while you can, but then if you zoom in too much, then draw inside of an inner one. Then if you zoom in too much, draw into another inner one or whatever. And then those, for example, this one from min int all the way to max int. Yeah, I mean, big int would, like, it would have the same issue as max int. Eventually. Like, it doesn't matter if it's bigger or if it's a smaller when it comes to like the ones and zeros. It's not like better to have more ones and zeros. So like this, let's say it's from min int all the way there, and this one might be at like let's say 10 all the way to 30, let's say, in this scale. Then you have like a huge grid, or a really fine grid relative to this one. Let's do 20. These are easier numbers to understand. I don't think it's going to be a real issue though on the X and Y axis. Because if you look at like how people use this, they don't really move much in terms of X and Y axis. Oh. Yeah, but this needs to be running fast, and I could have thousands of lines. Like here on this screen, I have 1,182 lines right now. I have 1,200. So you want something that's fast for the GPU. And then you have to run at 60 frames per second. Okay, so big integer is like a type. Oops. Big integer. They don't have code. Arbitrarily large signed. So I guess it doesn't care. I guess this one is the... But yeah, I don't think I need that. I thought the X and Y axis were the same as zooming in. But I guess there's a discontinuity. So when you draw a line, you draw based on your like where you're looking at. So let's say I don't care about the zoom, infinite zoom. But I'm just drawing from left to right non-stop without zooming in or out. So at some point I'll reach the edge of like the min int, max int. So what does that mean? Or is it possible or is it impossible? So in order to draw in a coordinate system, like the system picks a coordinate system so that everything is a whole number, but the grid is fine enough that like the grid is smaller than the pixels. So that allows you to not use floating point numbers. Then if you zoom in too far, then it just goes to a different coordinate system in like smaller. I guess in practice, it's not like this big one contains the smaller ones. They might not line up necessarily from like one edge to the next, all right? Depending on how I pick how the smaller ones are created. Let's say like a smaller one overlaps. Like this is impossible to get out of the parent like that. But actually, like this one, I guess works if it's part of like a bigger, instead of being part of this one, it can be part of a smaller one. Oops. Something bigger. So this one is bigger, and this one can be part of this bigger one. That's not really mathematic. Like, how does the system work? Like this thing that is like an AABB3 doesn't care. It also doesn't care about like overlaps or like how things are divided. But what I know for sure is that each one of those has its own data structure with its own coordinate system and camera system. It's more efficient to know what's on the screen if you don't have a lot of those on the screen at once. So one goal of the system is to make sure we don't create more than needed. So that means we have to pick good values for like zooming in and out. Let me uncap this system really fast. This, let's say we go to 400. This is a huge number. I don't think I could like zoom out far enough. Now we're like going really far. Let me draw this. Oh, yeah, we're using like exponential numbers. So now I'm at like exponential 26, exponential 30. And let's say I draw a line here. Does the line flicker? Not really, right? Doesn't flicker more than those one? I don't see a difference, do I? Interesting. Ooh. Oh, they disappeared. What does that mean? Exponential 41. Oh, and now my cursor disappeared too. Am I able to draw? Oh, I'm getting none. So I guess I can't draw here. Oops. Alright, so what happened on this? Oh, everything is none. Even the line. So I guess now that's... So would this be an issue though if we were using whole numbers? Let me just see. So A is none, B is none. Start. Current cursor is none. So the camera has a position, but we can't tell the size. Oh, is that how I'm going backwards? Wait, I thought I used the scale for this app. Wait, why did Z have a value? Oh, I used Z. Why? That's not the issue, I guess, but... I could skip a step. Yeah, whatever. So... camera. So my view matrix is just destroyed. Whereas like the values are too... Is that an issue I would get no matter what? Oh, that's cool. They have a demo like this. Is there anything smaller? Oh, there you are. That's cool. I didn't go deeper. Oh, could it be? Oh, this one is huge. I'm already lost, I think. Oh, shit. Oh, shit. Wait, let me restart. So there's a room. There are nodes. That's really well done. Oh, there's... Oh, what? There's stuff here. Ah, so this is an ongoing thing. Well, I wish there was a... I guess it's because we're in the browser. Oh. Oh. Incredible. There really is pixels in this. I wonder if this is something that's drawn out of the app that they put in here. Or did they draw this from the app? Then that would be why it's pixelated like that. Wow. So did they draw this separately and then paste it in? No, there's no way, right? Because it's featuring this app. Oh shit. They went all out. Wow. It never ends. Incredible. Can't wait to get to that point. Wow. We were like one little part there. Yeah. Didn't you see Imaginary Nightmares? Sorry. It's kind of annoying that it does that. Oh, we're not done. Spiral. Whoa. Oh, it's the end. All right. Can I find it? Can't be that. Well, I'm subbed to the channel and the YouTube thing can't find it. Oh shit, good thing I'm not showing that on stream because that's some truly creepy stuff. Oh, Artificial Nightmares, there you go. 2 months ago. 92 views. Is that it? Is that some music? I guess it's not the right. Popular. 2 years ago. You see? Kind of badass. That was before like the video AI things that were big. Oh, it's going back out. Two months ago. That's music, isn't it? There's words. There were some better ones. So it's using diffusion. It's kind of badass. Ooh. The AI like is trained on a specific picture, so it adds like those eyes everywhere, and then you can go in. It knows like about the facial features things. Guided diffusion AI video. So it's trained on like an image that looks like that. And then so everywhere you look it needs those features. So it adds them everywhere. Cool stuff. 10 hours of LSD. What is that? Yeah. I get no, same idea though. It does have like features, like this looks like a spider. So it's trained on a spider image. And then the next part is trained on like a city. And then this looks like birds maybe. Ah, okay, so yeah. So based on the chat word, it would train itself on the features. Yeah, we see like animals, different bugs. They like birds, flies. The other ones would take that I showed took probably a lot longer to generate, like maybe hours or days. All right. So I crashed. So when things become too small, I crash. It doesn't make sense though, because you end up with something that goes towards zero. There's no way around that. I wonder if it goes further if I use if I don't, let's see, Z. This is when you save. Okay, let's start here. This becomes camera.scale equals to scale oh, you don't need this part. What did I do? to vector 2. This is a flow. Oh, the scale is a vector 2. True. Okay. Oops. Oh, come on. Oh, scale doesn't exist. Wait, save cams is a cam. This means that, well, this is not backwards compatible, so I shouldn't do this, but I'll do it for now. Oops. Okay. Oh, come on. I think I got them all. Let's try. Okay, it still bugs at the same spot. It does make sense because the math is the same even though I did it like that. But I think I'll leave it on scale. Looks kind of bad, right, the text. Is there a reason? I guess it's because I don't smooth the points. Something that apps usually do. So that does mean that I have a huge range, right? Like it only starts bugging around exponential 40. And then in the other way, let's say I uncap on the other side. Where was this? Down here. Let's do minus 400. All right, let's go down here. Oh, oops. Let's go with this here. Now I'm at minus 5. Minus 8. So already it starts jittering. So we don't have as much tolerance on the when we go like really close. So I don't know how I can handle this better. I don't think having integers makes it better. That's just a fact of life, I think. You have to. So, wait, how did that happen? Let's go in. Yeah, already you're jittering. And then we lose it at minus 9. Did we lose all of them at minus 9? No. I wonder if there's something I can do. Like in theory, the smaller scale can represent the bigger scale losslessly, right? So it's just a matter of doing some conversion math from bigger to smaller. So like, for example, let's say like this is 1020 in like this system, and then in the bigger one, this could be like, let's say it's 50 all the way, let's say to 60. So then let's say there's a point here, I guess a point here. So in this coordinate, okay, let's say here, this would be, let's say this is 0 all the way to 10. So in this big coordinate, this point, let's say, is at 5 on the x-axis. And then I bring this point inside of the other coordinate system. It becomes, let's say, 53. And then this would be accurate, let's say. Oh wait, no, that's not how that works, is it? Wait, okay, already this doesn't work. Okay, wait, let me just... The coordinate doesn't work, the idea works, I think. Let's say this is min int. Whatever. And then for our purposes, like min int might be like minus 100, and then this might be plus 100, let's just say. And then here, so this is from 50 to 60 in the parent coordinate system. In other words, then this 1020 doesn't work because you have to be between. Oh no, it does work. But well, okay, whatever. It's just the drawing doesn't work, but whatever. So let's say you have a point here. Let's say this is 0 on the x-axis. Then you bring it inside of here. Let's say this inside there is like minus 10. And then you bring it in. Maybe this is like minus 70. Oops. So then it's a matter of projecting the bigger lines down into the smaller scales. That's kind of a pain to do, right? It does solve the jittering, but it's kind of annoying. And then zooming out is just a matter of not drawing things that are too small. Zooming in would be a matter of projecting the lines that are in view down into the smaller scale. you're not gonna have that many lines, right? On the bigger scale getting projected down as you zoom in. Yeah, it's a floating point issue, exactly. Yeah. So what I'm gonna do is, like for now I'm not doing it just yet, but coordinates for the lines. Where did I put it? Oops. Oh, I had it. This thing. Instead of being like vector 2a, vector b, b, and then this is a floating x, floating y, these become integers. The grid becomes smaller to make the integers have like the range of value to be displayed correctly on the screen. At a, like you'll be able to draw freely. And then when you get like zooming in or out, you run into like the floating points. Then you just go down into a different coordinate system. Or if you zoom out up into a different coordinate system, smaller lines that become like these are like too small, you can't see them. Those stop getting drawn at some point. So when their thickness is like so small that you can't even, like they don't make sense, then don't draw them. And then if you zoom in, then you have like a camera. I guess there's a point where the higher camera doesn't, like you run into floating points if you're zooming in too close. So at that point, I guess freeze that camera so it doesn't zoom in more, but project the lines that it intersects with down into the smaller scale. And then the queries can then be done on those. Yeah, caching what you remove. Oh, and then also, I'm using the AAB so I can add those bigger lines down into smaller scale. Dynamically and then remove them, it doesn't matter. Like as you zoom in, there are fewer bigger lines. That's like, has to be, that's kind of obvious, right? Like here, when I'm out here, there's like 1900 lines. But like if I zoom in like pretty much anywhere, like here there are 21 lines. Wait, that's a lot. I guess I drew on top of other things. This is still 21. I guess it's because they're all overlapping each other's. Here there are like 3-4 lines. So it's not like there are that many from the higher, unless you draw like on top. Now there are like almost 200 lines. But then as soon as you zoom in again, this drops to like 8, 7, whatever. So let's write my notes then. To do So that can be on a line by line basis. And then if you zoom like even further out, then that can be on the coordinate. So like then if you're like too far away, don't even draw all the lines in this data structure. Okay, one thing that is an issue is like the sorting order. That requires me to recode the batcher to draw the lines, to allow sorting between the different coordinate system. So let's say you draw like a huge background. You can project it down into, as you zoom, it gets projected down into the smaller scale. Wouldn't you stop drawing? I think as long as it gets projected down. I guess one issue would be if let's say like one of the let's say there's like a big background. That's a different noise. You heard that? It's annoying. At least it only happens when I touch it. Okay, so let's say you draw like one big background. I guess though, like everything in this is like just lines, by the way. So it's like point A to point B. Everything has that. So if I'm drawing a background, let's say that I draw it by doing like a big point like that. So that's one line. Then I zoom in on that. So let's say my line is like so big that it covers like it's like outside the possible points of this thing, of this coordinate system. Oops. Or outside the other coordinate system. I mean, I don't know if it can even happen in practice. Just because the X and Y range is like so big. I guess if like you're doing it from like way outside and you zoom in a lot, then it's possible. Because then this line can't be projected down. Is it a case where you have to just clamp it to the side, to like the shape of the... Oops. Where like you instead of using the point here and here, you use like a point somewhere in here and then somewhere in here. And then as you zoom in, So you find a point that intersects both the line and then the bounds. If you do that, then you wouldn't stop drawing it. I guess that doesn't work. Wait. I guess the main thing to wonder is like these coordinate system that encompass like min int, max int, or whatever. Like let's say I have them like, what's the overlap? Like, how much bigger is the bigger one? Let me just try this. Oops. Oh. since it's not gonna get squished. So the scale is 0.1 right now. When I'm around here, this is a scale of 1 for this coordinate system. Obviously right now I use floating point numbers, so I'm able to like go between the pixels, but so this is 1, and I said I can go all the way up to 4D before it starts having a lot of issues. Oh, we're already in exponential. Okay, wait, the thing that I'm supposed to do if I wanted to do this, but I need to code a second camera where the exponent is like offset from like the first. Then I can compare, like I can put a dot, let's say at, obviously right now it's floating points, but like at like minus 2 billion or whatever. And then I go to the other camera, the same point, and then see like the distance between the two, I guess. Then that gives me an idea to understand what's going on. Alright, I shouldn't end the stream though on this. So by doing integers, what it gives me is more range on the x and y axis. Yeah, that's the point of integers, I think. But then everything still becomes a floating point. So maybe I don't gain anything. Let's see how far I can go. Let's say I go like far here. I wonder if there's a point where it starts jittering. Or if it's never gonna happen. Where am I right now? What is this number? 91 billion? No, 91 million. Okay, let's do out a lot. Still fine. Maybe I'm solving a problem that doesn't exist. I thought like this would start jittering when I move like that. Where am I on the... I'm at 15. Trying to stay around there. What is this number? Minus 1 exponential. Why is there no jittering when I move like that? I'm kind of pissed that it's not happening. Oh, wait. No. So maybe it doesn't happen. Maybe I am solving a problem that doesn't exist. Like, we're really far right now. This is like... Isn't... Still looks fine to me. Oh, wait, it does get jitter. I mean, maybe you're right. No, but I feel like it should be apparent anywhere. Okay, wait, let me save camera 2 and then camera 3. I don't see anything weird. Why is this number allowed? And then camera 4, let's see. This number is like, I can't even visualize it. It's too big. I'm so far away on this. And the thing are like right there. Yeah, it looks too good. And this is where I was at the start, right? This is like scary. How mind-boggling. Things are right there. I guess when there will be issues, I will see issues on my cursor that I don't even need to draw. I need to be careful not to go too far, right? Oh, there's more stuff here. I went to 26, I guess. I can hold and then go back to the... Make a line from wherever this is. Because you're able to save, like, let's say I save a camera here, and then I'll put it here, then a camera here. Oops, where am I? And I can hold my mouse and go all the way to the other spot to draw a straight line to it. Okay, let's go all the way to 40, I guess. Oh no, 40 becomes none. Right. Wait, this was... This is the spot I was at. Okay. So now I'm really, really far. Let's zoom in here. Oh, there we go. So now I'm at 40, but my cursor disappeared. Oh, now it came back. But you see how it's like really bad? So if I draw... Oops. I should have saved. Yeah, it's just gone. But sometimes it wasn't gone. Oh, wait, there was an ABB. That happened so much later. But I guess it's like one thing that you can't predict as easily, right? Because it could happen. Like the error could be like really far, like where I went. But then depending on the zoom level too. So like when I was zooming in, it was disappearing. When I was zooming out, it was coming back. So out of range of the... So wait, what was the issue? It was because of the... Wait, let me see. A minus something, whatever. Let's see where A was. Let's copy this and try... Can I put that in Wolfram Alpha? One, 2, 3, 4, 5, 6, 7. That was a crazy number. I'm kind of impressed I can do that with floating point numbers. I guess I can't because it crashed, but that's because my AABB was pretty scuffed, I think. Wait. It's like this thing was so weird that the tree doesn't know what to do with it. Or is that a bug in my... Like should this thing has no nan anywhere, so shouldn't it be allowed? This is an internal add. I need to end the stream shortly. 5:29. Which line is it? Out of bounds. So I'm trying to read from an array. It could be like here maybe. Or like here. Or here. Or even like those here. Wait, can't I debug this really fast? Was that the trick or did I have to... Oh, I forgot. Let's just cheat a little bit. Let's go right away like to minus to like, and then let's just go far. Coming back down. Very jittery. Dang. Alright, can I go in? Oops. I forgot which project I had that showcased how to do that. Maybe this. I need all this. Or maybe just this. Or the whole thing. Oh, that works? So you're using floating points? I guess that's what other people have been doing too. Is it precise when you just do... I thought that was too easy. Give me 1 sec though. I need to find this crash. Surely here is fine. Ooh, you see that? Oh, it's gone. Oh, it's here, a branch index. What did it find? Oh, this search? -1? Oh, this thing doesn't... Wait, what? Reroute is this? It's not null. Wait, why does this return -1? This has to be a bug, right? Best index. That's -1. So whatever it did, it didn't find anything. Best index is -1. So why don't I handle that? It has to be a bug. I'm giving you a valid AABB, right? I mean, this has to be valid. So why does it not work? Rectangle to insert. It goes through this, and I guess this is never better. The cost of this union. This is a priority queue, right? If I remember. Queue. Yeah, priority queue. Yeah, I remember reading that they were doing that. Yeah. I remember that. They do, I think, the same thing with Outer Wilds.
Rejuvenation. Revitalization. Reincorporation.
That's fun.
Rebirth.
Mm. You do that in your code? I don't think I would ever dare do that. I guess if this is... It's a double negative, right? This becomes 0. And then it goes back. So if this is 10, you end up at like minus 10. Minus 10, you get back to 10, yeah. And it's an option I never really considered. I thought about it and I disregarded it right away. Origin shifting. But I guess it's one way of doing it. But can it really work in my case? Because everything can have like its own precise value. Won't I like still, like if I draw like super far, don't I end up with like issues anyways? Like the lines are static. And then they have like very precise values. Yeah, that's true. I think it doesn't work though. I mean, it works in the case of shifts, because then they're like on screen and then moving or whatever. Maybe I'm wrong. Does it work for really detailed? I wonder what they do in the game. What is it called again? Space Engine. Does he have blog? Space Engine. So that he did one thing and then never posted again. This one. Oh, so it goes to the future. Is there not an index? Articles, maybe? I guess not. It's news. Oh, it's already been 5 years? Wow. Oh, wow. You didn't know? Did you know about it? Space Engine? It's so good. Yeah. No, you can actually travel. I tried before. You can go like from one object and then anywhere you look, you can go there and actually travel. And then you can make your speed be faster than light. So you can like look at a star like really far away and then head right there. Then you'll have like all the objects like flying past you. Yeah. You can have like you can go specifically to where you want. This is I don't even know how it's possible to code this. It's just like too much. But I guess they must do the same thing. At least I know that this is really simple. It's simpler. Like the idea of the origin shift is that you can have really precise value around the origin, but then if you're really far, then the values are less precise. So it works well for a game because, I mean, the things become into view and they're precise, and then when they're really far away, you don't see them and you don't care about their precision. So in my case, let's say that I draw my lines, then it's all nice, and then I move my camera away, and then the lines, the position starts shifting, and then I come back, and then I think it will look like a mess. Because then when the lines get shifted back, like away from the origin, they'll lose their precision. That's what I think. Yeah. So was there a thing where I return? Let's say I add internal add. This is possible to fail. But I don't tell anyone about it. That's kind of bad. I'll have to think about this, I guess. This remove does return -1. But I guess if you ask to add something, you expect it to work. Maybe the crash should crash, even though the error is kind of weird. This is -1. Summary. This is for when you hover. I guess you can't hear, but like that. So it tells like what this does, and then it returns the leaf. So this is that. AAVV. It doesn't show on VS Code the things up here though. I think. Yeah. It should. I guess it shows it there as I'm filling it in. Item. Alright, I should end the stream, I guess. Not really as much progress as I thought, but I guess it's a hard problem to do this. I should like buy it and then try it. I don't have access. Do I have access to an iPad? Try to break it and see if it crashes or if there are limits that no one ever runs into. Like, can I zoom really far out and then go like really far away and then zoom in and draw? And does it stay fast always? This guy's really good. I'm guessing they allow you to paste images in. I guess once I solve the infinite canvas stuff, then I can do that too. Hey, did you guys see the other thing? What was it called? Floor 796? This thing? So there's someone called where's your it's an animation project anyways. So they add constantly more stuff to it. So you can like zoom in and then see like animated parts of like pop culture things. Oh, there's already more stuff than last time I checked. They have changelog, I guess 21 things. Forbidden? Probably because there's some naked people in here somewhere. Ooh. And then you can click and then see vs Jackie Chan, Luffy against someone. You can have all the references. Alright, it's already almost 6. I gotta go. Peace.